We start with lecture 1. What is fire engineering? This is the discipline that uses science and technology to make sure that our building, home, offices, and industries are safe from fire. Fire is the single greatest discovery of human history. About 1.5 million years ago, our ancestors in Africa started to stop feeding wildfires, and actually went back to it, started to investigate. And now fast forward to the industries and the technologies and the cities and environments that we have today, that the good fires, the managing of fires, the taming of fires has helped us to do. And not only just in power generation or in transport, but also in cooking, in metal processing, giving us comfort and giving us heat when it's needed, also giving us warfare. These are the uses of wildfire that humanity has learned to do. But there is also the bad fire, the original wildfires and the bad fires that happen inside the home, inside the office, inside the buildings. These are accidental or arson attacks, and they are not meant to happen, and they put people at risk with the smoke, which is always toxic, and the flames that can hurt and can lead to injuries or to death. So in this lecture series, we are going to be focusing on fires in homes and in offices, but we should not be forgetting also about the original fires that were a threat to humanity a long time ago as well, which continue being a threat, which is wildfires. When people or infrastructure are in the forest and there is a wildfire approaching, these people are in harm's way, and there is things that fire engineering can do to help them. Going back to homes and offices and industries, when we look into the best data set that exists currently of fire fatalities, which is in the United States, it is a large database that goes back in time about 100 years. When we look into this data, we see a continuous decay and a continuous decrease of the number of fire fatalities that has happened in the United States. This is a success story. This is what happens when we humans learn how to stop the bad fires, how fire engineering has actually managed to do that. There is a lot that we can learn from this data, not only of what are the specific things that fire engineering has done that has led to this continuous decrease of fire fatalities, but also what were the costs, what were the investments and the consequences of doing this, and how we can learn what happened and what could be happening, so we continue decreasing the number of fire fatalities even more. Fire engineering is a technical discipline of engineering. It's recognized, and it has been with name or without name present for a very long time. The first time that fire engineering started to be used was mostly in the United States and in UK, in Great Britain, after the Second World War. This discipline started to be used because of a sad story. During the Second World War, the Allies, both specifically UK and United States, invested a significant amount of science into incendiary bombs with the objective of causing fires in the homes of the enemy, namely Japan and Germany. When the war ended, both Allied superpowers realized that the use of this science could be actually converted into a net positive. Warfare is not netly positive at all. And this is the beginning of fire engineering informed by fire science. After the Second World War, when all these experiments and all these computer models and all these technical developments were focused quite vigorously to be used for the good. The objective of fire engineering is to protect people, protect property, and protect the environment. Regarding the protection of people and property, there is something that is quite interesting. Obviously, we protect people always. It's not about minimizing the number of fire fatalities. That's not an acceptable objective. Fire fatalities are not acceptable, and we try to reach that objective, although sometimes it cannot be met. So it is a global objective. Whereas for property, what we do is in fire engineering is we minimize the property damage. The objective is not to have a zero property damage. It is tolerable to have some property damage. We just minimize it. And this dual approach to objectives of fire engineering mean, for example, that regulations, national regulations and standards tend to focus on life protection, life safety. And very often, national regulations don't look into property protection, or they look very little in property protection. Property protection is dealt very often by insurance companies, by the private sector, by the industries themselves. The reason for this split is that national regulations, although they are absolutely essential and vary significantly across the world, they aim to the lowest level of safety. So national regulations are not in place to give the best level of safety, nor the maximum level of safety. They provide the minimum level of safety, such that if the level of safety is below what the national regulations is saying, then this building would be illegal. It would be too dangerous to be in. But there is plenty of space above the level of safety set by the national regulations. So when people say, my building met the national regulations, that's okay. They're saying that the building is legal, but that doesn't mean that it is going to be automatically safe, because there is going to be always a level of risk, and that doesn't mean that there is no space above to go for higher safety. There is a quote by Professor Vincent Brannigan from the University of Maryland, which I like to bring into this topic that we are discussing. He said, and I read, "The Titanic comply with all codes. Lawyers can make any device legal. Only engineers can make them safe." What he is saying, rightly so, is that safety and legality are not 100% linked to each other. We could have a building, or Titanic, that is legal but not safe, and we discover that afterwards. And we could have a building that is safe and legal as well. Once I was giving a talk, and someone in the audience asked me this great question. It said, if you have an infinite budget, how would the safest building would look like? And I realized that the safest building of the place, the safest room in the world, would be the International Space Station. Not because it's far away from humans or it's far away from Earth. It actually is because NASA or any space agency invests so much resources into making sure that the space in the International Space Station is safe in terms of the plastics and the polymers that they use, the materials, the ignition sources, the suppression, the detection, that it has actually ended up being the safest place in the planet, being slightly out of it. Now, how many of us can live in the International Space Station? So it's not just that maybe we don't want to live there. It's also that only a handful of people can actually live there or has lived there. So realistically speaking, we are not going to have the budget of NASA for the design of spacecraft. We need to do buildings that are comfortable, that are affordable, that are beautiful, that are appealing, that are safe. The International Space Station maximizes safety, but it's not affordable, and it's actually maybe not that pretty. So there are other examples of buildings that are very safe, but that no one will want to live there. Two examples. One is a bunker. Think of a Second World War bunker in the coast of France. How many of us would like to live there? Well, not many, but it's very safe. A bunker is designed to be extremely robust to fire, to the point that even if fire arrives, it will not actually collapse, and it will maintain the people inside safe. Another example, an igloo. If we go to the Arctic, if we go to the North Pole, and we see people are living in igloos, igloos are actually really safe, not only because it's really cold, and actually means that the ignition process is more difficult. Not only that if there is a fire, the igloo and the ice of the igloo will melt, and it will be the best suppression system possible. It is also that if you see how igloos are, they have very few things inside. There are very few fuels that can be inside. So an igloo is actually a very safe system, a very safe building to live. How many of us would like to live in an igloo or can actually afford to live in an igloo? Not many. So these three examples are three examples of tremendously safe buildings. And these are three examples of why we should not let fire engineers design homes and offices. They should be part of the design process. together with architects and the other engineering disciplines. But it should not be down to the fire engineer how our homes are done, because we will be ending with houses that we don't want to live in. So we've seen that the safest buildings that we could think of are not the nicest buildings to live in. So it is important to allow the building industry to innovate and to make homes that are comfortable, appealing, affordable, on top of being safe. I'm going to discuss now 3 innovation drives that are causing fire hazards, are creating fire hazards, and makes fire engineers to have to learn about these hazards before these innovations can be fully deployed in the building environment. The first of these drivers is sustainability. Sustainability is this very important modern principle of society and engineering that takes into account what happens also outside the system and the design. So it's not just about the building, it's about what happens with the surroundings and the environment around the building, what happens after the building stops being a building. So it's very modern. It takes into account environmental issues, recycling issues, circular economy, climate change, carbon emissions, pollution, community leadership. All these aspects are part of sustainability. From the point of view of fire, there is this material that is arriving again into the built environment, which is timber. We've been building timber for millions of years, and some countries like Scandinavia or the north of America use timber extensively. But we're talking about a different use of timber. We're talking about tall timber, high-rise buildings made of timber. Architects have already taken the decision that they desire these buildings to take place. They love them. They're very pretty. They have this sustainability ethos in them. It has been proven that the psychology of people inside buildings where there is timber being exposed, the psychology of these people is more positive. The material is lighter, is faster to build, is inexpensive or is not as expensive to build, and also is engineering from the point of view of engineering is strong enough now, thanks to what is called engineering timber, like CLT or Gulam. It's strong enough that can actually be used for the structure of high-rise buildings. This didn't happen before. One of the issues, the main issue that the architects and some authorities are facing is that how to make these high-rise buildings safe from fire is not trivial. It can be done, but there is a discussion around the community of how it should be done. The origin of the issue is that timber, which is wood, burns. And we know this because nature made timber and nature allowed timber to burn in forest fires. If there is a fire in a high-rise building and the wood of the structure gets involved, this alters the fire safety and alters the fire hazard of the building. So it needs to be addressed and it needs to be looked at. The image that you see over here, it is a tower, a high-rise building made of timber that has been proposed to be built in London. It has not got approval to be built because there are issues, among them the fire safety issues. Other cities like New York, Tokyo, all around the world, there have been architects that had put forward tall timber buildings. We have experience of plenty of buildings made of wood that have burned, and we've learned from them. The fundamental issue when we build tall timber is that as timber is involved in the fire, it starts to lose section. So the fire is heating up the wood starts to burn. In the burning process, it acts to the fire, but also the timber structure starts to be thinner and thinner and thinner because the fire is consuming its section. Because the timber is the structure of a tall timber building, then there's a point where the cross-section could be such that the structural part might start to collapse partially or totally. So it is fundamental at the fire level, understanding how wood burns, so we can actually understand what is the mechanism by which wood loses section, such that structural engineers, can take this into account and design a structure of a tall building made of timber that can take into account that loss of section through to fire. So it's two things that happen with a fire in tall timber. One is that the wood burns and adds to the fire, leading to a different fire that has to be fought. It has to be evacuated from. The compartmentation has to fight that specific fire that has to be altered by the wood. And the second one is, so that the first one is life safety. And the second one is that the structure might collapse partially or totally, which is an issue of property protection. So in timber, in the design of timbers, we have one is dealt by life safety, which is mostly taken care by the regulations. And the other issue is about property protection, which is about the structural collapse of the tower, and is dealt with insurance companies and at some point also by regulations, but mostly by insurance because it's about property protection. I want to tell you now about the other driver, and driver of innovation that is making our homes better and nicer and our lives better, which is not related to a building itself, but is actually related to what we bring inside the building and into our lives, our pockets, our cars, which is related to energy. And is this revolution with the lithium-ion battery. Ubiquitous technology, tremendously successful. We're very thankful to this technology that is giving us all these information breakthroughs and revolutions, and is allowing little gadgets be power everywhere, portable, and also big gadgets like cars being power. They are even bringing these batteries into our buildings as stations that will be able to store energy and allow the grid to be stable and stabilized. So one of the problems with this technology is that lithium-ion batteries are flammable in the sense that they actually burn themselves, they add to the fire. That is just not the only reason. The reason is they themselves, the lithium-ion batteries, can be an ignition source. So in a way, the lithium-ion battery is a system that has a significant level of flammability attached to an ignition source. If the ignition source goes wrong, we're going to look into the possible ignition sources that go wrong, the battery might start to burn. This is an image, 3 images taken from a video that was shared online in YouTube recently. It was taken by a private citizen in the UK during the pandemic in a park, and it's a scooter with an electric engine fed with a lithium-ion battery that when they were in the park, it started to malfunction. Not clear why malfunction. Apparently there was not a specific abuse to the battery. It just decided in that moment when they were outside to start to ignite, and it led to about in 5 minutes to the complete loss of the scooter. It's not just the loss of the scooter that was dramatic. Is that imagine what would have happened if this fire would have been inside the house of the owner. So the owner says, I am very lucky this didn't happen at home. And I do think they were very lucky when this happens at home. When a lithium-ion battery happens in a closed environment where there is people around, the hazard is quite severe. Lithium-ion batteries, we are happy to say that they are rare. This is a table with the most important lithium-ion battery fires in the last 10 years or so, until the year 2019 when we stopped counting. We need to update this table. You can see over there, I recommend that you stop the video and you take a look at some of these cases. These are very high-level cases. These are the ones that made it to the news. It was relatively easy for us to collect them and bring them here to you. You know that this is the tip of the iceberg. In reality, there are hundreds of these, some of them much smaller. But lithium-ion batteries fires have led to the recall of laptops, recall of cell phones, recall of electric vehicles, recall of scooters, recall of many, many different technologies because of fires that had led to dramatic consequences. So companies have lost a lot of money, people have lost lives, and it has affected the community. One of the big questions that we have around lithium-ion batteries is not that they are more flammable than the systems they're replacing. For example, the electric vehicle is not more flammable than the petrol engine vehicle. And people look into the statistics and they start saying, well, the petrol engine cars have more fires, have more frequent of a fire than electric vehicles. Therefore, electric vehicles are safer. That's fine. I'm happy to be part of that conversation. The conversation or the worry for fire engineers is not in the frequency or which one is more flammable. The conversation is that this is a new hazard. Electric vehicles and battery fires is a new hazard. it behaves in a different way to the previous hazards that we have learned how to deal with. For example, in homes, we protect homes mostly about sofas and mattress fires and textile fires. We protect parkings against gasoline and diesel engine cars getting into fire. The fact that we are bringing a system that has a different ignition route, it has a different speed of development, it has a different toxicity to the smoke, it is completely different how to suppress it. That is what concerns our engineers and lithium-ion batteries. So it's not the frequency and it's not the damage. It's that the solutions that we have did not consider a new hazard like this one. As more lithium-ion batteries are present around us, fire safety engineering needs to catch up and protect life, properties, and the environment from this new hazard. I can tell you right now what you have in this figure. These are, for example, the known routes of ignition of lithium-ion batteries. For example, we know that the lithium-ion battery can ignite because it has been abused electrically speaking, also known short circuit, or it has been abused mechanically speaking. It has been a perforation and it has been part of an impact. Or it could be that it's thermally abused in the sense that it has been surrounded by a high temperature environment and that has led to the battery to ignite. There is a fourth mechanism, less study, with my group has been involved in this, which is when the battery is stored, or maybe after it has been used and is being recycled and is about to be disposed, and the battery is not plugged in and there is no charging or discharging of the battery, is not being used and no one is mistreating it mechanically, but actually they could actually self-ignite. Self-ignite is the ultimate, most worrisome source of ignition, is when the device itself, without any external event, can ignite by the process of self-heating, which is a very slow process of generating heat that accumulates in the battery, raises its temperature until there is a thermal runaway. So with this, I would like to finish lecture 1. In lecture 1, this one that we're finishing now, we have brought to you what is fire engineering, that its main objective is the protection of life, property, and environment from fire. This hazard that has been with us for many thousands of years and will remain with us, unfortunately, for many thousands of years. We see how important it is for fire safety to catch up with modern buildings and to be present with us. Modern buildings cannot be understood as comfortable, affordable, healthy, and fair if it were not to be also because of fire engineering that has made the environment safe and is going to make the environment even safer. And the last bit to say is how, as the building environment evolves and new materials, new ways of building, new sustainability drivers, energy drivers, how, as the building changes, fire engineering has to change and address the new hazard that has been created. With this, I finish. Thank you very much and see you in lecture 2.